Hi there. This video is going to be about Hall effect sensors and what the Hall effect is and how the Hall effect sensors work. So what's on screen is an example of a Hall effect sensor. You can tell that it's a Hall effect and not an inductive sensor because it has 1, 2, 3 connections, and you can see the 3 wires on the back of this connector. Okay, move on to the next slide. Here's a wiring diagram or a schematic for the layout of a Hall effect sensor. This is meant to represent something like a flywheel. Let's say it's a crankshaft sensor. So this is the flywheel and these are magnets or magnetic points. And every time a magnetic point passes the sensor, we will generate a signal. You can see the 3 wires. So we've got a voltage being supplied to the sensor. We've got an earth return or a ground from the sensor. And the 3rd wire is our signal, which would go to the ECU. Okay, how does it work? Well, to show you that, I need to do some background stuff. And I've had to borrow my dog biscuits. So credit to him. Here they are. Here are the dog biscuits. What I've got set up here are 2 threaded bars, which are meant to represent a conductor, so a piece of copper wire, let's say. And the dog biscuits themselves are meant to represent the negatively charged electrons. Let's just try and run this video. And you can see the electrons moving through the conductor. This is a sketch of a piece of equipment known as a cathode ray tube. Okay, so in my cathode ray tube, I have 2 electrical connections, the cathode, which is this one, and an anode, which is this one. And what's going to happen when we throw the switch, the electrons will flow through the cathode, and there'll be, because there's a vacuum inside this tube, all the air has been drawn out, the electrons can jump across the gap between the cathode and the anode, and lots of them do, and they move very, very fast. You can see there's a hole in the anode, and so as a consequence, some of the electrons that are moving so fast across this gap can't stop and they go through the hole, and we end up with a beam. Okay, so I'm just going to run the video and you'll see the electrons flowing through it. Okay, so I've thrown the switch, the electrons are starting to flow through and you can see them. There's a beam of electrons or a cathode ray. Okay, so this is an actual cathode ray tube. Before I run the video, I'll just point out a few things. You can see the cathode here, here's the anode, and here's the beam of electrons going through. What they've got is a special gas inside this tube so that you can actually see the effect of the electrons. Just try and run this video. So there you go, you can see the electrons shining through into this cathode ray tube. Now what I'm going to do in a moment is hold up a magnet. So here we go. Just watch the effect of the magnet on that beam of electrons. Okay, and if we turn the magnet round, so we've got the south pole, you can see the beam of electrons flying upwards. Let's just try and explain what's going on there. Okay, so what I've done here is brought in my multimeter, and if I connect one of the probes to the bottom and one to the top, when the magnet is there, although it doesn't show it on my multimeter, there would be a very small voltage. There's no current flowing because the main current is flowing through the conductor, but just by swinging the magnet towards the conductor, you produce a potential difference across the top and the bottom of that conductor. So every time a magnet passes the Hall effect sensor, because the electrons move to one side of the conductor, we end up generating a signal. So what I've got here is my drawing of a Hall effect sensor. You've got the supply voltage, which is one wire. You've got the earth wire, which is another wire. What I'm not showing on this diagram is my sensor wire, but I want you to imagine that would come off the top here somewhere. Okay, so basically, whenever my magnet is lined up with the Hall effect chip, I would produce a voltage here. Okay, so whenever the magnet's there, we produce a voltage here. Okay, I just wanted to say thanks to Dexter for letting me use his biscuits. See if I can get that video to run. There he is. Okay. Thanks for watching.